Hello, everybody. Welcome to topic 1.1 notes. So you are going to take these notes in your lined notebook or lined composition book. And again, I don't care how you take notes as long as you are taking good notes. So think back to the note-taking stations we did the first few days of school, and you can decide how you want to take these notes. Okay. So I'm going to be kind of looking back and forth between my screens here because I have some of my own notes on my other monitor. So if I'm looking back and forth, that is why. So let's go ahead and get started here. So AP Biology has different topics. And so we are starting with Unit 1 and starting with topic 1.1. So let me see here. Got to turn off the drawing function. All right. So we're going to talk about water, okay? Surprise, water. Water is essential for life. It's essential for us to live. And in fact, with living things, about 70% of our body mass is made up of water. So it is super, super important for life, right? And today we're going to talk about the structure of water, okay? So what does molecularly the structure of water look like? So let me move my screen here. Okay. So, a water molecule. I'm sure you have all heard of water molecules before. H2O. Okay. So, that is called H2O because we have two hydrogens, which is the H2 part. And then we have one oxygen. Okay. And we can see here that the hydrogens are positive and the oxygen is negative. Okay. So, we have these polar covalent bonds that form between the H's and the O. Okay. And we also have this uneven sharing of electrons, and this is what makes water a polar molecule. Okay. And as you can see, water has two separate ends to it. Okay. So it has a positive end with the hydrogens, and then it has a negative end with the oxygen, right? So again, hydrogens are positive, oxygen is negative. And again, feel free to pause throughout the video or rewind if you need to write something, but please do not write word for word what is on my screen. You're going to want to write more of the words coming out of my mouth, what I'm saying, than just copying down what is on your screen and moving on, okay? So again, make sure you are summarizing. Do not write word for word what is happening here, okay? All right, so with water being polar, it makes one end slightly positive and the other slightly negative. So if you've ever had like magnets, like I've had like these like snake egg, I don't know if they're called snake eggs, but these like magnets where you try to put them together and they just won't go together, right? You're trying to push really, really hard, they just won't go together, right? That is because those two ends of that magnet, if they have like the same force, okay, so here we're talking about poles, okay, and this is kind of getting into physics, but just for the example, if we have two of the same charge pushing against each other, that is why they won't connect, right? They do not want to touch together, okay, so they're gonna push apart, push apart. They're never gonna stick together, right? Um, so we can remember that water is polar because if you ever heard the word like polar opposites, right? I've been told my brother and I are polar opposites. So we are on the opposite ends of the spectrum, right? So we are on different sides, okay? So again, with one end being slightly positive and one end being slightly negative, we know and we've heard in chemistry and life, opposites attract, right? So, and we can see in this diagram that this north and the south pole are joining together, okay? So these opposite charges in nearby water molecules form hydrogen bonds, okay? So the hydrogen bonds are what connect different types or different water molecules, okay? So again, opposites attract. We have this negative oxygen that connects to this positive hydrogen, okay? And they're connecting via this hydrogen bond, okay? Now, we have millions of tiny water molecules in like just a droplet of water, right? We can't see them. They are molecular. We don't see this even with a microscope, right? So we have millions of trillions of billions of whatever of water molecules in just a tiny drop of water, right? And these water molecules are hard to pull apart. They're sticky, okay? And they're not sticky in the sense of like I touch like a residue of tape or something, right? They're not sticky in that sense, but the water molecules like to stick together, okay? So if I have two water molecules here, they are going to stick together with these hydrogen bonds. They are not going to want to break apart, okay? They are stuck together with those hydrogen bonds. And so, make sure I have everything I need to here. Again, they're pulling together those water molecules, okay? And they're not quite like ionic or covalent bonds if you've taken chemistry, or if you are taking chemistry. They don't quite hold the molecule together itself, like the water molecule itself. But they bring two different molecules together and just makes it really hard to pull those two apart, okay? So, we discussed water molecules take a lot of force to pull apart. Again, they're sticky. They want to stick to each other, okay? So, these hydrogen bonds are the reason why water exhibits all of these other properties that we're going to talk about, okay? So, we're going to talk about temperature of water, okay? So, we're talking about why water has a high specific heat capacity, okay? High specific heat capacity. So, that is one big thing we're going to talk about. So, make sure you like write this down, you highlight it, something like that, okay? High specific heat capacity, important information, okay? So this means that it takes a lot of energy to heat up water, okay? Now, temperature is a measure of the kinetic can't talk. Temperature is a measure of the kinetic energy that mass has, okay? So kinetic energy is like moving, okay? So we know we've learned about solids, liquids, and gases in elementary school, probably middle school, right? Liquid molecules are moving around, right? So they're just kind of vibrating together, right? We know that gas molecules are kind of bouncing around all over the place. We know that solids are like staying really tight together. They're not moving very much. Water is kind of in between, okay? It depends on the shape of the container, depends on the molecules, blah, 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 blah. But we know that the water is a fluid, so these molecules are going to be moving around, right? So in order for the temperature of water to rise, so like if you're making mac and cheese on the stove, okay, we want to boil the water. We want that temperature to rise, okay? Now, what's going to happen to these water molecules, and we can see with this graphic, I know it's kind of blurry, but temperature is getting moved up here, and we can see what happens to these water molecules, right? They start out in this nice square shape, right? And then they get faster, right? They're getting faster and faster. And so these molecules have to move faster in order to be heated up because of this specific heat capacity. Water has a high specific heat capacity, okay? Now, the reason why it has such a high specific heat capacity is these hydrogen bonds, right? These hydrogen bonds are holding the water molecules together, okay? They don't want that water to be bouncing around going crazy, okay? They're trying to stick together. They're polar, okay? So what has to happen when we get to like a boiling point or something like that with water, when we're heating the water up, it takes a lot of energy to break those hydrogen bonds apart, okay? So that is the reason it takes so much energy to heat up water, because we are actually splitting those hydrogen bonds, okay? So the other part of this is temperature regulation, okay? So this little guy here um, cannot regulate his temperature like us. So humans, mammals, okay, we can regulate our temperature, right? If it's really chilly and freezing out, we don't just die, right? We get really cold, we want a coat on, but we are able to regulate our internal temperature and keep it pretty steady, right? So we are made of 70% water, right? And again, water has a high specific heat, okay? So we are really good at staying at, I think it's supposed to be like 97 point something, okay? Our internal temperature, when you go to the doctor, they're like, your temperature's good, you're great. Oh, you have a fever. Oh, your temperature's low, right? So water has a high specific heat, and that makes it easier to regulate our internal temperatures, okay? So this little guy, he cannot regulate internally, okay? So that is why when you get a lizard, you have to have a heat lamp for them to bask in the sun, or if they live in the desert, they're wild, they have to bask, right? And they have to bask for a while, okay? Because they have to absorb enough of that heat to raise their temperature back up. Okay, again, they're made of a lot of water. So they have to absorb enough heat to raise their temperature of that water back up in their body. And again, the reason it takes so long is because of water's high specific heat capacity. Okay. All right. So another thing we're going to talk about with water is the high heat of vaporization. Okay. So it takes a lot of energy to turn water into gas. So again, water, H2O, starts out, we are normally talking about a liquid, right? And it takes heating up water to 100 degrees Celsius to get it to turn into gas. Okay. So let's talk about when we sweat. Let's talk about evaporative cooling. Okay. So when you sweat, you release water from your sweat glands, right? We end up with water on our skin like that, wiping our sweat away when it's really hot outside, right? But if you just let the sweat be on you, right, it would eventually go away. It would eventually evaporate, right? So remember that water has a high specific heat capacity, okay? So again, eventually the sweat droplets are on you. If you just let them be, they will eventually disappear. They're not just disappearing, they're evaporating, okay? And when they evaporate, they take that heat from your body with you, okay? So it's really, really hot out. It's really, really hot out. You're sweating, you're sweating. And so what is happening when you sweat is that water is on your body, okay? It evaporates. It takes some of that heat with you so you don't just overheat and die, right? Sweating is a regulation mechanism for us, okay? So when we sweat, okay, again, we sweat, that sweat evaporates, it takes some of that heat with it, okay? So that we aren't just turning into a toaster, right? We are getting that heat out, okay? So again, this is really, really important for temperature regulation. All right. The next thing, we're going to talk about a few properties of water. So we're going to talk about first about cohesion. Okay, if you've ever heard the prefix co, it means together. Okay, so water molecules stick to other water molecules. Stick to other water molecules. So again, what sticks them together? Hydrogen bonds. Yeah, you got it right. Good job. So if you ever see like a spider web like this, right? One of these little droplets here is not one water molecule, okay? That's made up of billions of different water molecules, okay? But they are all just sticking together because of those hydrogen bonds. So this is cohesion. And again, we can see we have the negative oxygen and we have the positive hydrogen, okay? And that is what is sticking together, okay? And we can also see, we're going to do a lab where we're going to put water droplets on a penny. Okay, we're going to see how much can it hold. Okay, because those water molecules like to stick together. Okay, maybe it's happened to you where you like go to pour yourself a glass of water and you're not paying attention and you accidentally are like way over pouring the cup and you're like, oh shoot, I gotta stop pouring this. And then it's like right at the top of the cup and it's like just over the lip of the cup. And you're like, this is amazing, right? That is because of cohesion, okay? Now, adhesion. So this is when the water molecules stick to polar surfaces, okay? So we can see in this graphic, adhesion is holding on to the surface of whatever it's in cup. It could be like your body, it could be like the surface of a plant, whatever it is, okay? So one example of this is capillary action in vascular plants. So we know plants need water, right? So that water comes from the roots and it goes all the way up to the tree, right? Goes all the way up to the leaves, okay? So that water has to travel up there. And not only is it traveling all the way up a big tree, it's traveling against gravity, right? So it needs to have some sort of way to actually get up there, okay? So this would not be possible without these different properties of water we're talking about, without cohesion and adhesion, okay? So with cohesion, the water molecules kind of stick together, and you can see that here. they stick together and um kind of guide each other up, right? They're like holding hands with their little hydrogen bonds and they're going up the xylem. And the xylem is just um like the inside of the trunk here. Okay. And then so they not only stick to each other, but they stick to the walls of the xylem. Okay. So we can see with this key here, we have adhesion sticking to the walls of the xylem. So it is able to travel against gravity by sticking to each other and sticking to the walls of the xylem. Okay. And then also, if you think of adhesion, you think of adhesive, so like tape, glue. Okay. That can also help you remember. All right, surface tension. So this makes water molecules cohesion, makes it take some force to break the surface. Okay, so cohesion. Okay, so again, those water molecules sticking together. Okay, that's why like these water striders here. Okay, they are able to like walk on the surface of water because of those hydrogen bonds. Okay, it takes more force to break those bonds. Okay, that's why. So like I was on the dive team for 1 year in high school, and when I was really scared of like belly flopping when I was doing my dives, my teammates would like kick the water under the diving board. They would kick it so it wasn't just a flat lane of water. They would kick it and break up the surface tension. Okay, so then I wouldn't belly flop as hard because they were breaking that surface tension. Okay, so it makes it take some force to break the surface. Okay, so again, that's kind of goes with cohesion. Okay, so a recap. So water molecules have an uneven sharing of electrons. So for example, with these polar covalent bonds, and water is polar. Okay, so these slight positive and slight negative charges result in hydrogen bonds that form between negative oxygen and positive hydrogen atoms. Okay, so these hydrogen bonds form between different water molecules. These hydrogen bonds are what give water its properties. Okay, so again, water molecules require a lot of energy to break apart from one another. Water has a high specific heat and a high heat of vaporization. Okay, so this makes it good for temperature regulation in living things. And then because of surface tension, water sticks to itself very well. So this is cohesion and surface tension. And then it also sticks to polar surfaces. So this is adhesion. Okay, so think of it sticking to like leaves or even like when you get out of the pool, right? You still have like droplets of water on your body. This is an example of adhesion. Okay, and then so these properties allow for capillary action in vascular plants. Okay, so I hope this video was enlightening. Remember that you need to have these notes done for your week 1 homework, and I hope you have a great night.